graphing the cosine wave. Graphing the cosine wave won't be much different than graphing the sine wave. Still need all the same characteristics of period, amplitude, starting point of phase shift, and increments. But just getting started, it's going to be nice to know what the values of cosine are on a unit circle. Let's go back again to the unit circle. If you remember, cosine were all of the x values. So all of these x values represent cosine, just the x coordinates, all the way around. So that's the reason why this is as theta, the x values. So let's say theta was 0, or 90, or 180, 270, 360. If theta were any of those numbers, it would be these x values. So at 0, x would be 1. At 90, x would be 0. At 180, x would be -1. At 270, x would be 0. At 360, x would be 1 again. And of course, if you went further and you went to 450, you would have went from 1 to here. That would be 0 again. So it started to repeat. The pattern would go on and on afterwards. So those are the numbers that we actually need, and that's where those numbers come from. They actually come from the actual unit circle. Now let's graph it. This would be the theta axis. This would be the x-axis. So instead of being y, it's now the x-axis. This is the theta axis. So my x values range between 1 and -1. So my highest number is 1, lowest number is -1. And my theta values are 0 to 450. So this of course would be 0. This would be 90, 180, 270, right about here would be 360. And then I'll try to make this equally spaced on the lines. So right about here would be 450 degrees. All of these are degrees. And what's really important when we actually get started with this is actually plotting those points. So at 0, my output was 1. So at 0 for theta, output's 1. And then at 90, output 0. So at 90 is right here on the axis. At 180, output's -1. So at 180, it's down here. And then at 270, output 0. So at 270, it's back on the axis again. At 360, output is at 1. So here's 360. Here's 1 again. At 450, output's at 0. So that's 0. And I can keep going further and further, but that's enough, because that's going to be more than one period anyway. So when I actually graph this curve by connecting those dots, it looks like this. Starts here, goes down through this point, back up through this one, back down, and right here. So obviously, it did all the things it needed to do. It went down for a while, bottomed out, started coming back up again, then went down again. And technically the curve continues to do the same thing. So it'll go down again, back up again, and so forth. But again, what we understand about period, we're looking for where that cycle begins and ends one time. So if that's the case, we can start it here, and it ends here. So that one length there is your period. So that's one period out of back. So that's the period of the cosine curve. If you notice, if it starts at 0, it ends here, which is 360. So the period cosine is 360. Or in radians, 2 pi. How we find it using the equation is just like in sine. It's always going to be 2 pi divided by b. b being the number in front of x. So this equation says y is equal to a cosine b theta subtract c. So in this problem, the a value is still the number in front of cosine, which is 1. The b value is the number in front of theta or x, which is also 1. So I confound it and knew my period is 2 pi by knowing that. But that's the period, that's a graph of cosine. Look like this. And I always tell kids, if you graph the whole curve, more than one period, it doesn't look much different from sine. But if you want to find one period for cosine, always think about this curve right here. Let me make it a different color. Always think about this curve right here. Kind of to me looking like the Texas Longhorn symbol. If you ever watch college football. So whenever you think about the cosine curve, think Texas Longhorns. It's not a perfect cosine curve, but you get the point. So Texas Longhorn, cosine. So give a new one, and the direction would be graph y equals 2 cosine of theta. So the characteristics are still the same. Amplitude is still absolute value of a, period is still 2 pi over b, the starting point is negative c over b, and the increments are still the period divided by 4. So in this case, a value is right here. The b value is right there. It's the number in front of theta, which is 1. So if that's the case, my amplitude is the absolute value 2, which is 2. And my period is 2 pi over 1, which is 2 pi. My starting point, because I have no parentheses and nothing being added or subtracted there from theta, is going to be negative 0 over 1. So it's 0. And since my period was already decided to be 2 pi here, it's going to be 2 pi over 4, which reduces to the power of 2. So those are all the important characteristics, and now we're going to graph it. So I know my starting point is at 0, but it's actually going to be a pi at first. And each increment is going to be pi over 2 from the last. It's going to be 1 pi over 2. The next one is going to be 2 pi over 2, 3 pi over 2, and 4 pi over 2. So when I actually graph it, I know that this point right here is my max intercept. It's going to be my minimum right here, intercept, maximum. So it goes down and back up. And that's one period of the curve. Just don't forget, curve continues forever. But one period of it is here in yellow. And that's what that graph looks like. I want to graph one period of that equation. So here's the new equation. You try to graph this one on your own. So pause the video and see if you can find the period, amplitude, starting point, and the increments, and see if you can actually graph this equation. Good luck. So you should have found the amplitude to be the absolute value of negative 3, which is 3. And you should have found the period to be 2 pi divided by b. Well, the b value is here. It's 2. So it should be 2 pi divided by 2, which is pi. You should have found the starting point to be negative c over b, which is a negative pi all over 2. Makes it positive pi over 2. And don't forget though, there's several names for starting point. Sometimes that's a starting point, or certain books say starting point. Sometimes they would say horizontal shift. And sometimes they may say phase shift. All those are the exact same words. All those are different words, but the exact same thing, negative c over b. So again, I just want to make sure we're clear on that, because it's kind of important to know this vocabulary, as we move forward. The last thing are the increments. And the increments is going to be a period over 4, where it can be pi over 4. So I know my increments are all pi over 4 from the last. So from there, I hope you graphed it. It should look like this. So you should see a graph look basically like this. But the thing is, though, you actually have to, my tick marks are not exactly where they should be. So this would be a starting point. This would be an intercept. This would be a maximum, because that's where the maximum is. And this would be another intercept. And this would be where the one period ends. So if you remember, because the amplitude is 3, it should go up 3 and down 3. But since that's a negative, instead of starting off at 3, it's been flipped. It'll start here, down here at negative 3. And then it will go up, back down again. And that'll be one period of that curve. And that's what it looks like. Those increments, if you started here, which is actually pi over 2, each increment is pi over 4 from the last. So you basically have to take pi over 2, add pi over 4 to it. See that those have the same denominators by multiplying this one by 2 over 2. Making it 2 pi over 4 plus pi over 4 is 3 pi over 4. I mean, the next increment here is at 3 pi over 4, which is great, because when you take 3 pi over 4 and you add pi over 4 to it, you get a nice easy pattern to work with. 3 pi over 4 plus pi over 4 is 4 pi over 4. I mean, the pattern is everyone's going to be 1 pi over 4 from the last. So this would be 4 pi over 4. Here would be 5 pi over 4. Here would be 6 pi over 4. So yours may have those numbers, ultimately graphs or something like that. And that's it. That's how you graph the sine, the cosine graph.